All right. Hello, Emily. So I'm just going to go through these notes as if you were actually in class. So this next and last lesson is divided into 2 days. So the first lesson you would have received on Tuesday, and then to finish up this lesson, it's going to be on Wednesday. Thursday, we're reviewing for the test, and then Friday is the actual test. So these are the notes from day one, which will be on Tuesday, September 5th. This last topic is something called literal equations, and more on that in just a second. But we're going to be starting class with just a little warm up. So I want you to go ahead and try this warm up. And so go ahead and pause the video because I'm going to go right into solving this. So the warm up says if that you have this equation x plus 2 over 3 all equal to m, and then you're given that m has a value of 5 and you need to solve for x. So this is a type of problem that we should already be able to do given lessons from last week on proportions. So we're given some really important information here, the fact that m is equal to 5. So wherever we see an m in this equation, specifically right here, we're going to get rid of it and write 5 instead because we know that m is 5. So I'm going to go ahead and rewrite this equation. So x plus 2 all over 3 is equal to 5. I'm not going to write 5 though. I'm going to write it as a fraction. So 5 can be written as a fraction as just 5 over 1. Again, I didn't change that number. 5 over 1 is still just the same thing as 5. From here now, I just need to cross multiply in order to solve for x because I have two ratios equal or proportional to each other. So to solve, I cross multiply. The first cross multiplied items are x plus 2 and 1, but anything times 1 is just whatever that number, variable, or whatever it is. In this case, it's just x plus 2. So x plus 2 times 1 is just x plus 2. And that's going to be equal to the cross multiplication of my other two items, and my other cross products are 3 times 5. So all equal to 3 times 5. I'm going to simplify this because I know what 3 times 5 is. So on the left-hand side, I still have my x plus 2, all equal to 3 times 5 simplifies to be 15. From here, it's just a one-step equation. I have to get x by itself, so I have to get rid of this positive 2 term right next to it. So I do the inverse operation of that. I subtract away 2. What I do to one side of my equation, I have to do to the other, so I subtract 2 on the right-hand side as well. When I simplify, on the left-hand side, a positive 2 minus 2 cancels each other out. It's just 0. So they go away. That was the whole point of doing that because all that's left on that side now is just x, which is exactly what I want. And that's all equal to, okay, on the right-hand side, I actually have 15, but I'm taking away 2, which is now simplifies to be 13. And I receive my answer. What is the value of x? Oh, here, I just solved for it. X is equal to 13. So from there, we would actually go into the lesson for the day, which is on this last topic called literal equations. So what is literal equations? It's basically just the process of solving an equation for one specific variable. So it's the process of solving an equation for one specific variable. So far, what we've been doing in class is we have been given like an equation, like a one-step, two-step, or multi-step equation, and there's only been one variable. And in algebra, if there's an equation with just one variable, we can kind of manipulate the equation to solve for the exact value of that variable. Kind of what we did up above. Yeah, technically this actually had two variables, x and m, but we were able to get rid of that second variable m and replace it with 5 because that's what I was told m was. So if you only have one variable in an equation, then you can kind of manipulate that equation just like we did here in order to solve for that exact variable x. But with literal equations, there's going to be more than one variable. There's going to be 1, 2, 3, 4, maybe 5 variables. I don't know. It depends on the question. There's going to be more than one variable, and you're going to have to manipulate the equation in order to solve for a specific variable. And in doing so, you will never know the exact value of the variable that you're trying to solve for because there's more than one variable. You're basically going to get an equation at the end. So this is going to be kind of different, and it's also going to be a little complicated. I think this topic is the toughest and it's going to be the hardest. So when you return, I would highly encourage you to come to ASP, my ASP second period, because you're going to need help on this. It's a tough topic. So don't be ashamed if you don't get it. It's tough. Many people are going to have issues. But the notes down below. Everything on the left-hand side, we should be able to do. All these are our one-step or two-step equations. On the right-hand side is similar problems, but instead of having just one variable, we now have multiple variables. The problems you will see are very similar, and the processes that we'll be taking are also very similar, but you'll see that with literal equations, it is just a little different. You're kind of manipulating the equation with nothing but variables. So it's just a little different. So let's talk about the stuff that we do know first, and then after that, we'll talk about how literal equations is just a little different. So looking at this first one, y minus 9 equals 34. This again is just a one-step equation. I'm going to try to emphasize things with colors. So any step that I'm taking, I'll use red. And then on my work, when I simplify things to go to the next step, I'll show it in pencil. So to solve this equation, y minus 9 equals 34. And I'm being asked to solve for y. Well, I'm trying to get y by itself. Again, if I look at this equation, on the left-hand side, I do have my variable y, but I have something along with it. There's this term minus 9. I need to get rid of this term minus 9 in order to truly solve for y and get y by itself. So I need to do the inverse of minus 9. I have to add 9 to both sides. Again, what I do to one side, I have to do to the other. And when I do that, this whole negative 9 plus 9 on the left-hand side, because they're inverse operations, they cancel each other out. Negative 9 and positive 9 combine to be 0, so they go away. And I'm left with just y on that side. I got my equal sign in the middle, but then on the right-hand side, I have 34 plus 9. So when I combine a 34 and 9, let me see. So I got my calculator here, 34 plus 9, those combine to be 43. So on the right-hand side, I have 43. When I look back and reflect, I notice, oh, wow, I'm actually done. I figured out what y is. Y has a value of exactly 43. So this, again, is something that we should be able to do. That was just a one-step equation. Let's take a look at what this looks like when we solve something called a literal equation. So notice on the right-hand side, it looks very similar. We have some variable, c, just like we had the variable y. And then we're subtracting off, a variable d. In our previous problem, it was an actual number 9. But then we have our equal sign, and then to the right of the equal sign, we had 34 on this problem over here, and now we have a variable. Dang, there's lots of variables in this problem. These two problems, however, are almost the exact same problem. The only thing is this whole minus d is now a variable instead of minus 9. Like, we don't know what d is. It could be 9, it could be 10, it could be 50. We still have this equals some number e. Yeah, it's not equal to an exact number 34, but again, this equation is pretty much the exact same format. We have something minus something equals something. Something minus something equals something. Because the format is pretty much the same, we're still going to be following the exact same process. However, we're not going to be moving numbers around. We're going to be moving variables. But again, the rules and process are the same. Nothing really changes. I'm being asked to solve for c, the variable in this spot. Notice that's the exact same thing that I was asked to solve for here, y, the variable in this spot. Well, to do that, in order to get c by itself, so I have my two sides of my equation, the left-hand side and then the right-hand side. If I'm being asked to solve for c, which is this variable right here, c is unfortunately not by itself yet. It has this minus d kind of tagged along with it. So what I need to do is, to get c by itself, I have to get rid of this minus d term. Well, how do I do that? It's the exact same process as before. I have to undo a minus d here. Well, what's the inverse of subtracting d? Well, the inverse of that is adding whatever that number is. It just happens to be a variable, d. So I'm going to add d to both sides. If I do it on this side, the left-hand side, I have to do it on the right-hand side as well. So I'm going to add d to this side. Notice, though, when I added d to this side, I did not put it underneath this variable e. The reason I did that is because this e in this d variable, they're different letters, so they're not like terms. We cannot combine them together. So when I simplify, again, a negative d plus d, I'm taking some number, some negative number, and adding it to itself. Well, that's just going to cancel out. It's kind of like taking negative 5 plus 5, or negative 5,000 plus 5,000, or negative 1,000,000 plus 1,000,000. Whatever that number is, if I add it to itself, it's going to cancel itself out. So all I'm left with on the left-hand side is just c. I got my equal sign in the middle. And then on the right-hand side, I have a variable e, and then I'm adding d to it. Again, these are not like terms, so I cannot combine them. I literally write it just like that. Now, what's typical is that things are usually written in alphabetical order. So d comes first in the alphabet. It's positive, so I don't put a sign in front of it. And then this e, there's no symbol in front of it, so it's assumed to be positive. So I'm going to use the addition side to indicate that e is positive. This is my final answer. I've solved for c in terms of my other variables. What I did is I just moved d to the other side. C is all by itself over here. And what this equation is saying is, well, in terms of c, this variable then is equal to whatever d is, and then add it to whatever e is. So this is my final solution. Again, it's kind of the same over here. My y was equal to my 34 plus my 9. So it's kind of like my 34 is my d, my e is my 9. So the only difference between these two types of worlds, before we were able to solve for the very specific value of our variable y, because we only had one variable. We were able to solve and notice that it was 43. However, with literal equations, there's just tons of variables. So what we're doing is we're not solving for exactly what c is, we're just solving for what c is in terms of the other variables. So that's what a literal equation is. It's just manipulating an equation using the rules that we've learned in one-step, two-step, and multi-step equations. So moving on, try to go a little faster now because I kind of broke that first problem down immensely. So I'm hoping that helped. So problem number 2. Again, this is something that we should be able to do. Negative 6x equals negative 30. When we have a number like negative 6 right next to a variable, x, it's assumed to be multiplication. So this negative 6 is multiplying my x. Well, to get x by itself in this case, I have to do the inverse operation of that multiply by a negative 6. Well, the inverse of multiplication is division. So now to get x by itself here, I have to divide both sides by that coefficient in front of x, the negative 6. And when I do that, negative 6 divided by a negative 6 is just 1. So any number divided by itself, like negative 6 divided by negative 6, it's just 1. Well, that's the whole point of doing this, because now my coefficient in front of my x variable is just 1. So I have 1x all equal to, now on this right-hand side, I have a negative 30 divided by a negative 6. So negative 30 divided by a negative 6 is 5. So I get my solution. X is all by itself over here. I've solved for x. My x has a value of 5. Well, let's do something very similar, but let's look at it from the perspective of a literal equation. Here we have, you've probably seen this formula before in middle school, because you guys talk about a little bit about geometry with something called circumference of a circle. So circumference equals 2 times pi times r, which stands for radius. Well, in this particular problem, I want you to take this very famous formula, very popular used formula, but I want you to solve for it in terms of r. So I want this r to be all by itself. The problem is I have a pi right next to it and I have a 2 right next to it. Now this is all one giant term. Remember, terms